Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. Side DC of square ABCD is tangent to the circle shown in the figure. If each side of square is A, what is the diameter of the circle in terms of A? So we are given a square ABCD and there's also a circle drawn in the figure. And this is quite unlike the typical problem where you get a circle either inscribed wholly within a square or a circle that's totally circumscribing a square. In this case, the circle that we are given, it's neither the circumcircle, it's not circumscribing the square in the strictest sense, neither is it inscribed in the square. So that makes this problem somewhat atypical, but that doesn't mean it's a difficult problem. Again, we will follow a very step-by-step systematic approach to tackling this problem. First, we start with naming some of the points. For example, let's call the points where the sides AD and BC meet the circle as E and F respectively. And let's also call the touch point where DC touches the circle as T. So if we join B to E by the straight line, and I'm showing it by a blue dotted line, consider angle BAE. So that's 90 degrees because angle A, ABCD being a square, angle A is 90 degrees. So angle BAE is 90 degrees. And further, B and E are points on the circumference of the circle. So that makes BAE, the angle BAE, an angle in the semicircle, because we know that angle in a semicircle is 90 degrees. And if we converse that, we have an angle here on the circle, BAE, that's equal to 90 degrees, right? So that means this angle BAE has to be the angle in a semicircle, which implies that BE has to be a diameter of the circle. And let's call the length of BE as D. So now consider triangle BAE. In that triangle, one of the angles, namely angle BAE, is 90 degrees. And the side AB is basically the length of the side of a square, which is A, right? So we can apply Pythagoras theorem. So we have AE square plus AB square is equal to BE square. And we know that AB is A and B is D. So we substitute that. We get AE square plus A square is equal to D square. And from this we can obtain AE is equal to square root of D square minus A square. So we can mark that in the figure, that AE is equal to root over D square minus A square. Next, what we do is, from the touch point T, we draw a line that's perpendicular to DC, and hence it will be parallel to the sides AD and BC of the square. That's pretty obvious, right? If it's perpendicular, then it has to be parallel to the sides AD and BC. Furthermore, it's given that DC is a tangent to the circle. So if I'm drawing a perpendicular to DC, through T, so the touch point, then that perpendicular has to pass through the center of the circle, right? But we also know that the center of the circle lies on the diameter BE. It has to be on the diameter BE. So from these, you can conclude that the point O where this perpendicular meets BE has to be the center of the circle, because this perpendicular has to pass through the center. And further, we know that the straight line BE, that's diameter, so the center ought to be on the diameter. So from these two, we can conclude that the center of the circle is basically where these two lines meet. And let's call that the point O. Now, from O, we draw a straight line. So that's shown by the red dotted line. We draw a line parallel to AB. So consider for a moment the triangle ABE. So we have located O, which is the center of the circle, and B being the diameter, it has to be the midpoint of BE. So O, in effect, is the midpoint of the side BE. And now we are drawing this red dotted line that passes through the midpoint O of side BE and is parallel to the other side AB of the triangle. So the point where this red dotted line meets AE, let's call that point M, that point therefore has to be the midpoint of AE. So this is from a basic middle school to high school geometry theorem, right? If you draw a straight line through the midpoint of one of the sides of a triangle and parallel to the second side, it will meet the third side of the triangle at its midpoint, right? So that's the theorem I'm using here. So AM, in effect, will be half of AE, M being the midpoint of AE, right? So AM is basically half of whatever AE was. And we know that AE was square root of D square minus A square. So that will make AM root over D square minus A square divided by 2. So we have these dimensions now. Let's just clean up the figure so that we're not confused. So as the next step, what we do is we extend out the line MO to meet the side BC of the square, and let's call that point as N. Now essentially we have two rectangles formed. So the first one, I'm calling out by name, the first one is MNCD, rectangle MNCD. And the question is, what are the sides of these two rectangles? So we know that one of the sides is simply the length of the square A, right? And what about the other side? What about MD? Well, MD is essentially equal to OT. And OT, remember, O being the center and T being the touch point of the tangent, right? So OT will be the radius of the circle. And we have taken the diameter as D, so the radius of the circle will be D by 2. So MD, the other side of this rectangle MNCD, will be simply equal to D by 2. So we can calculate the area of this rectangle MNCD. We know that one side is A, the other side is D, or rather D by 2. So we have A multiplied by D by 2, which is AD by 2. So that's the area of rectangle MNCD. What about the area of the other rectangle that's formed, which is namely ABNM? We know what its sides are already. They're already marked in the figure, right? One of the sides is A, the other side is root over D square minus A square divided by 2. So the area of the rectangle ABNM will be simply A multiplied by square root of D square minus A square and then divided by 2. But then what is the sum of these two areas make up? Well, you can see from the figure that the area of the rectangle, if you take the sum of the area of the rectangles A, B, and M, and M and C, D, you basically end up with the area of the square, right? And that's equal to A square. So we can write this equation, AD by 2 plus A multiplied by square root of D square minus A square, then divided by 2, and that will be equal to A square. We can see that A is common on both sides, so we can cancel out one of those A's. And then we end up with this. Root over D square minus A square is equal to 2A minus D. So this is simple to derive. We basically, cancel out one of those A's, and then we multiply by both sides of the equation by 2, and on rearranging the terms, this is what we get. Root over D square minus A square is equal to 2A minus D. And now we can square both sides just to get rid of that square root on the left hand side. So we get D square minus A square, and then on the right hand side we have 2A minus D whole square, which I have expanded out. So that becomes 4A square minus 4AD plus D square. Again, we see that D square is present on both sides, so we can, let go of that term. And on rearranging the remaining terms, we basically obtain this. 4AD is equal to 5A square. And again, A being non-zero, we can cancel out one of those A's from both sides, and it's easy to obtain D is equal to 5A divided by 4. So it's 5A by 4. So the correct choice will be option C, 5A by 4.